Here we find out that Sentinel-2, all of Sentinel collection, Sentinel-1. Okay, so I want to work with suppose Sentinel-2 multispectral instrument. This dataset I want to use. And here we find out that you can see the surface reflectance on top of atmosphere reflectance. So I want to use suppose surface reflectance. So this surface reflectance data set, if you check, we find out this type of scale. Okay, so basically this type of suppose reflectance value, suppose aerosol, blue, green, red, it mainly this data set mainly provide as a digital number. So this digital number we need to convert into reflectance value. Okay, so for converting we need to use this type of scale. Okay, so not only for that, you can also check suppose other data set, suppose Landsat, surface reflectance. We also find out this type of scale value or offset value. So this type of scale value or offset value we need to use to convert digital number into reflectance value for converting. Okay, otherwise it not show the proper reflectance value or electromagnetic value is not showing properly. It show the digital number, very high value. So when you just multiply this type of scale value, then it just show the proper reflectance value or wavelength value we find out proper. Okay, so let's go, just simply import this image collection in our code editor. Just a paste. So now you can put any name as a variable. Okay, so before the variable name, we already know about that. Always use the var keyword and put any name. We can put any name as a variable. In this case, I put the name suppose image collection, or in this variable I simply put. So now this is my image collection. So this image collection I simply store it in this variable. Yes, any question please? Yeah,
Sir, I have a very small question.
please.
That is, sometimes we say for Landsat image it is 30-meter resolution, for Sentinel it is something else. What does this mean?
Okay, so basically it's called the resolution. Basically it's depend on the pixel size or grid. Suppose when you zoom a photo, suppose when I any photo, it can be Landsat or any photo, when you zoom more zoom, okay, then we find out the some square size sample or square grid we find out. So this type of square grid size is 30 meter for Landsat. This type of square grid size is the 30 meter, mainly pixel size. It's called the pixel size. So when pixel size is high, then we find out the resolution is low. Suppose I have a pixel size, suppose 1000 meter. So my box or my grid is also big. Okay, so then we find out the resolution is very low. But when I have the pixel size is low, suppose I have a pixel size only for the 10 meter, so 10 meter, so then I find out the lot of small grid, we find out on my image. So then we find out the high resolution. Okay, suppose if the pixel size is high, then we find out the resolution is low. But when your pixel size is high, then we find out that resolution is low. Okay, basically if the pixel size is high, then we find out the resolution is low. Okay, so then this image is not good. If the pixel size is low, then we find out the resolution is high. So that's the reason we just use the different types of sensor. Suppose Landsat is one kind of sensor. So this Landsat pixel size is 30 meter. Okay, it means that this square, suppose this grid or this cell, it's the 30 into 30. Okay, square meter area, 30 into 30 square meter area. So this, it means that suppose 30 meter means that this cell size or this grid size 30 into 30 square meter. Okay, this square meter area, it means that. Okay, and when you work with suppose Sentinel, we find out that it's a 10 meter pixel size. So this cell size 10 into 10 multiply 10. Okay, so we find out that 100 meter square. Okay, 100 meter square. Yeah, so now you can see we find out that it's a total 900 square meter for the Landsat, but Sentinel is the 100 meter square. This cell size. Okay, cell size basically cells is area. Okay, cell size basically 10 30 meter 10 meter, but this area when you compute just simply this. So we find out that it's a 100-meter square area and it's a 900-meter square area. So now when I work with, suppose I want to work with sentinel, so when you sentinel we find out the lot of 100-meter pixel. Okay, suppose if I suppose this is my study area, suppose this is my study area, this is my study area, I simply draw. So this is my study area. So this study area, when I use sentinel, then we find out the 100-meter pixel size. So suppose it show the 100-meter pixel size. Okay, 100-meter pixel size, all of pixel. And how much pixel, we can also compute this type of things also. So I'll also try to show you that how we can easily calculate the pixel number. Basically it's called the frequency. So pixel frequency we also compute after something, then you can get the more better idea. But now you can check, if I just use the sentinel, suppose this this study area, then it show me the all of pixel or grid, all of grid show the 100-meter square. So now it increase the cell number. So it help you to increase the cell size or number, we can say. Suppose cell size or cell number, it increase when I apply the 100-meter. But when I use the 900-meter square, so then cell size is not increase. Okay, so we find out the low cell size than sentinel, because it's the 900-meter. So you can check, suppose this is the 900-meter, also this is the 900-meter, so it's easily fill up. Okay, just suppose few cell when I work with the Landsat. But when I put the sentinel, then it provide the more cell, because it's the 100-meter square area. But when you work with the 900-meter, we find out the very few cell. Okay, not mass. Okay, less than sentinel we find out. So now what happened? So if this cell size is we find out the 100-meter square, then cell size is increased, then cell size is increased. But when I put the 900-meter, cell size is decreased, mainly low cell we find out, or decrease. I just write decrease. So now what happened? So it's a 100-meter, it's a 900-meter. So 100-meter, it's lot of cell. Okay, we find out the big cell number or cell size is increased when I use this study area. It means that it provides you the more information. So every cell or every grid give you the information, mainly pixel value. Suppose in this case I just use the 100-meter in this area, mainly 100-meter, mainly sentinel. So then it creates a lot of cell, and lot of cell give me the more information, and my image quality is also high. But when I work with Landsat, suppose for this area, so 900-meter square per cell size, then we find out the only few cell is cover my study area. Suppose cell size is very high, cell size is 900-meter. So then it not provide you the more better resolution, or it not provide you the good information. Okay, so this is the basic things about the cell size and how it will be worked. I hope you can get the idea. Not only for that, we also use the different types of cell size. Suppose modis have the different types of cell size. Modis, it can be, we can use 250-meter cell size, also use 500-meter cell size, also use 1000-meter cell size. So different cell size. So from this we can get the one idea. When you work with a small study area, suppose I have a only for very few small study area, or very not very mass big study area, then we try to use the freely sentinel-2 is more better. So for the small study area, when you analyze, you try to use the sentinel. But when you work with big study area, you can also use the Landsat, no problem. But when you suppose for you have the only for the small study area, then you try to use the sentinel. But sentinel have the another limitation, because this sentinel is available from 2015 or 17 something, 2015 to 17 it's available from 2015 or 17. But Landsat, it's available from your 1973 or 2, something like that, it's available. Okay, modis maximum it's available from 2000. Okay, so this is the way. Sometime we need the historical data analysis, suppose land use, land cover changes, or vegetation changes, or flood mapping, different types of work for the historical data analysis. Then we try to use here the Landsat data. But for the present time or near real time or real time, so this type of condition, sentinel is very work well. Okay, Modis is also help you because Modis is ready-made product. It provides a lot of ready-made product. We can also already use the Landsat or NDVI, so it also help you. Okay, as well as sometime we also use the different types of other data. Suppose we simply use the drone imagery. Okay, so it's also more high resolution. Okay, as well as we also use some commercial satellite imagery. Suppose commercial, so it also more high resolution. Suppose spot. Okay, spot 1, spot 2, spot 3, as well as we also use at the maxer. Okay, so it's the commercial, this type of satellite, or we can also use at the planet. So different types of commercial satellite imagery is also available. So we also use for the more small area. Okay, more small area when you try to work, or also we also use the lidar data. Okay, this type of things. So this is the basic things about that for the pixel size and resolution. So if the pixel size is low, then we find out that it's a high resolution imagery, and if the pixel size is high, then we find out the low resolution satellite imagery. Yes, please, any question? Yeah, please.
Yes, thank you for that kind of explanation. And my question is about what is the interval in terms of all these platforms? Maybe I just want to maybe use the drone imagery and then later integrate the Landsat, the Sentinel, the Modis. Is it possible? Like, how many days interval does this platforms provide the images?
Mainly you just merge Landsat, Sentinel, and Modis. Yeah. Okay, I don't guess it.
Sorry?
Okay, I cannot understand your question.
Like, what is the interval at which you can get the images? Like,
Oh, revisit day.
Sentinel.
Revisit. Yeah. Is it revisit day? Suppose revisit basically, suppose for the same place, when I get the image, it's called the revisit. Suppose for the Landsat, it's the 16 days. Okay, every new place we find out the imagery for the 16 days. Sentinel, it's the 4 to 5 days we find out. Okay, and mode is it's available for the different times. Suppose 8 days, or some data says 32 days, and this information you also find out in our data set. Suppose you can see it show the information 5 days. You can see the revisit interval, it's the 5 days. Okay, suppose revisit, suppose I am in Dhaka city, so I need the next image in the Dhaka city. For the 5, after 5 days I find out this. Revisit every 5 days we find out the satellite imagery in the same place. For the Landsat, we find out the 16 days. Okay, and Modis have the different temporal we find out. Okay.
Is it possible to know, like, maybe I just want to compare between the drone imagery, like, and even with Sentinel, so that I can take the images at the same time, like for a small plot area?
Yeah, it's also possible. You just simply merge. We can also merge, suppose Sentinel data and also drone imagery. Then we'll also check it. No problem. It's also possible to it. Okay. It's also possible. Okay, so I hope you can get the idea about that, how we can either work this type of resolution or cell size. Okay, and how to correlate with the image quality or resolution. Okay. Okay, so this is the image collection I simply imported. So now this image collection need to filter. So where you need the image, and how you need the image, and when you need the image. Just apply this 3 condition and filter. We already know about that, how we can easily filter this type of satellite image collection. So let's go. I will try to show you that. And I want to filter this image collection in the 2 season. Okay, this is my main goal. Suppose I want to filter this image collection in the rainy season and summer season. In year of suppose 2024 or any specific year. Suppose just put here the filter.
I can't see your screen.
Yes. Now it's okay. Huh?
Yes, it's okay.
All right. Okay, just put here suppose filter bounds. So filter bound basically where you need the emails. So for that we already know about that. We can simply import our study area. any shape file or anything, simply put. Just pop from the asset tab, just import your shape file. So, and work with suppose Dhaka city boundary. Just post, and I put the name suppose RY. So here you need the image, I need the image for RY, so just put here RY. Okay, so this is the higher you need the image, then I simply put here suppose when you need